This is the continuation of our video for the topic trigonometric substitution. Okay, on the previous video, we have already discussed problem number 1, and now we're going to discuss problem number 2, which is the integral of 1 over the square root of 9 plus x squared with respect to x. So here, let me just pull up my pen. Okay, here we go. So here, our given expression is the square root of 9 plus x squared, and this could be written as 3 squared plus x squared. And again, from the given expression, we could say that 3 is the side one, and x is also another side of a right triangle. So let's draw a right triangle here. Here we go, and this is our theta. All right, but the question here is which side is x and which side is 3. But then again, what we usually do here is that we want to make sure that we can get or express a trigonometric expression or equation in a simpler manner. So we try to put x on the numerator, and we need to find the denominator here, right? However, if we're going to use x as the numerator, so it could be an adjacent or the opposite. But in this case, we could say this is our x and this is our 3, okay? So this would be our 3. We should be using the value of, the simple expression of x and a constant 3. So which means this is tangent or opposite over adjacent. So we're talking about tangent here. All right, and the hypotenuse here is equal to 9 plus x squared. And based on our table or the guide, now when we have an expression 9 plus x squared, we should be using tangent, okay? So here this becomes x is equal to 3 tangent theta. So this is now our simpler equation, okay, using the given expression in the problem and using the right triangle, all right? So, and here we need to identify or express the square root of 9 plus x squared in terms of the trigonometric function as well. So what we need to do is to find an expression of 9 plus x squared. And we know that the square root of 9 plus x squared is the hypotenuse, okay, of a right triangle. So in reference to the theta, the square root of 9 plus x squared is the hypotenuse, right? And of course, again, we should be using a constant here, and the constant is 3. So this is an adjacent. And what trigonometric function do we have as the hypotenuse and adjacent? So we have the secant, okay, hypotenuse over adjacent, and also we have the cosine theta, this is theta, is equal to adjacent over hypotenuse, right? However, we want to express this, okay? We want to equate the square root of 9 plus x squared to a simpler trigonometric function. So we try to deal with secant, since we can easily get the hypotenuse, which is the square root of 9 plus x squared. So we have secant theta is equal to the square root of 9 plus x squared over 3, right? So we have the square root of 9 plus x squared is equal to 3 secant theta. So we have already found or expressed the square root of 9 plus x squared in terms of a trigonometric function, and also x as a trigonometric function. So we're now ready to integrate, okay? And let's just use a different color to identify the parts of the integral that we need to find a value. Okay, so we have already identified this. And oh, we haven't found the an equivalent expression or an equal expression of dx in terms of trigonometric function. So what we need to do is to use this, okay, to find dx. So dx, or the derivative of x, is equal to dx, and the derivative of 3 tangent theta is equal to 3 and secant square theta. All right, with respect to theta, of course. So we have already found this and this. We're now ready to integrate number 2. So let's now copy. So we have vx, sorry, all right. We have 9 plus x squared. Okay, so let's substitute the values. Dx is equal to 3 secant squared. Okay, let's write it here. 3 secant squared theta with respect to theta. And our square root of 9 plus x squared is 3 secant theta. 3 secant theta. And here we can do cancellation. We can simplify the integrand here. So let me just use another color. Okay, we can cancel 3, 3, and also secant, right? So what we have now is change the color. Okay. So what we have is the integral of secant theta with respect to theta. So, but the question is, do you remember, or can you remember a direct formula for the integral of secant theta with respect to theta? There is, and we have already discussed this in or under trigonometric integrals, right? Okay, so the integral of secant theta d theta, or with respect to theta, is equal to the natural logarithm of secant theta plus tangent theta plus c. Okay, and again, we have already discussed this under the topic trigonometric integrals. Now, we have already found the integral of this expression. However, the integral, I mean, the answer that we have right now is in terms of a trigonometric function, but the given has no trigonometric function. The given is expressed in terms of x. So we need to convert or to express the secant theta and tangent theta in terms of x. Okay, so let's go back to the triangle. So as we can convert this secant and tangent to an expression that we desire to express it to. So we know that this is 3, this is x, and this is our 9 plus x squared. All right, now let's just check that. Let's check if we have the same, if we have the same illustration or right triangle. Yeah. Okay, so we have the same right triangle, same sides, okay? X, 3, and the square root of 9 plus x squared. So for secant theta, secant is shot. So hypotenuse over 3, so that's 9 plus x squared over 3, okay? And for tangent theta, that's opposite over adjacent, that's x over 3. All right, so we can now substitute these values of secant and tangent theta in the given integral. All right, so let's just write it here. So our final answer is the natural logarithm of secant, and secant is equal to, let's write it down here, 9 plus x squared over 3 plus the tangent is x over 3. Okay, plus c. So this is now our final answer. And if we're going to check, all right, and interpret the given integral, okay, or the antiderivative. So we have 9 plus x squared. It was also, this answer is also expressed in terms of x. So which means that we have already expressed our antiderivative into its form, okay, to its original form. So we have already expressed our final answer. Okay, and I hope we have the same or equal answer in number 2. Okay, so let's work on problem number 3. Now, if you want to answer this by your own, you may pause the video and solve. Okay, once you're done, you can continue playing the video and check whether our solutions and final answer are the same or equal. So let's solve problem number 3. Now here we have quite complicated expressions or integrand based on the, okay, in relation to problems 1 and 2, right? Or problem number 2. So the radical expression that we can see in the given is x squared plus, x squared minus 16. Let me, let me erase that. Okay, change the color to yellow. So that's x squared minus 16. Okay, and based on the table, the guide for trigonometric substitution, if we have this kind of expression, then we will be using secant, if I'm not mistaken, right? But let's illustrate or confirm that here using the right triangle. So we can easily use the right triangle. Oh, sorry. So let me erase. We can easily use the right triangle to confirm if the function that we are going to use is actually correct. All right. So even if you were not able to remember the data or the given formula and restrictions in the table, as long as you know how to use the right triangle, then you can easily solve the given integral that involves trigonometric substitution. So here, in this expression, since it's x squared minus 16, we know that this is our, or let's just express this into x squared minus 4 squared. All right, so we know that this is our hypotenuse and this is one of the sides. So we are sure that this is x, and we need to identify where the 4 should be written. It's either here or on the adjacent part of theta. Okay, so let's just plot it here. All right, and since we need to look for x, so we put x here, and x is the hypotenuse in relation to theta, and we could put, what's this? Secant, so sha, right? So adjacent, we can put 4 here. And here is the complicated expression, which is x squared minus 16. All right, so this is 4. And since this is hypotenuse over adjacent, that's secant. So based on the table, we will be using secant, right? Here we go. So they're just the same. And x is equal to 4 secant theta. Okay, so we already identified the x here, right? Okay, good. So we're now good to go. However, we have not found the equivalent expression of the square root of x squared minus 16 in terms of trigonometric expression, and that's what we need to find out right now. So we have, let me erase that. Here we go. Oops. Okay, here we go. So here we want to know and we want to identify this. We want to get the equivalent expression of this in terms of trigonometric function. But for us to do that, make sure we can easily find a simpler expression or trigonometric expression in terms of this, okay? And we want to put this expression on the numerator such that we can easily solve for this in terms a trigonometric function, right? So here, we can use this and at the same time the constant. So better deal with constants in this instead of dealing with x and another complicated expression here, okay? So we can use the constant. And if we're going to find the position, okay, or determine the position of these values in terms of the right triangle, then we have This is our opposite, and this is our adjacent. So that's OWA, adjacent. So OWA, that's TOA, right? Tangent. So tangent theta. Okay, so we already found or expressed. Oh, so let's write it here. So for tangent, theta is equal to the square root of x squared minus 16. There we go. So we have already found this. Oh, we haven't found the equivalent expression of dx, right? However, we have here x. And for us to find the dx, we need to differentiate this expression, but we don't have space. So let's move on to the next slide. So we knew that x is equal to 4 secant theta. Okay, so to find a dx, we should differentiate both sides. 4, and the derivative of secant is secant theta, sorry, tangent theta. It's supposed to be tangent theta. So let me erase and yellow. Okay, so secant tangent theta with respect to theta. Okay, here we go. So again, we have already identified this, and this. So we're now ready to substitute these trigonometric functions or expressions in the given integral, okay? So we have the integral of the equivalent equation or expression of this is, let's move, right? So we have 4 tangent theta, okay? So here it is. 4 tangent theta, okay? And what's the equivalent expression of dx? Dx is 4 secant theta tangent theta d theta over, what is x? Our x is 4 secant theta, right? Okay, here we go. So we're now going to, or we have already simplified, we have already expressed this given problem in terms of trigonometric functions. And that's why it's called trigonometric substitution. And we're now ready to cancel. So let's cancel this, okay? And what we have now is the integral of 4 tangent square theta with respect to, with respect to theta. All right, and let's simplify the expression. Since it's constant, we can put it as a coefficient, and tangent square theta with respect to theta. Here we go. So our main concern now is 4 times the integral of tangent square theta with respect to theta. In here, let's review. Do you or can you recall a formula, a direct formula wherein the integral of tangent square theta is given? Okay, or do you know any formula what an integral of tangent square theta is with respect to theta, of course? For me, I don't remember any. I can't recall any, but based on the trigonometric integrals, now I can, or we can solve for the integral of this by, okay, converting, okay, tangent square theta to its equivalent expression using the trigonometric identities, wherein we know that tangent square theta is equal to secant square theta minus 1. Because we know that tangent square theta plus 1 is equal to secant square theta. Okay, so to find tangent square, we have tangent square theta is equal to secant square theta minus 1. So this is what we substituted here. Okay, so let's continue. Let's simplify. So we have 4, let me just copy. That's secant square theta minus 1 d theta. Okay, let's distribute or integrate term by term. So we have 4 secant square theta with respect to theta minus 4, the integral of 1 with respect to theta. So we have the integral 1 and the integral 2. So let's solve for the integral for every integral, okay? So we have 4. I'm doing this because I want to make my solution shown systematically, all right? So as I will not be having a hard time later to identify where should I place all the integrals for this term and for the integral of this term, okay? So I have 4 secant squared theta d theta. Okay, now, do you recall or can you recall a formula, a direct formula for the integral of secant squared theta with respect to theta? All I know there is, that's equivalent to tangent, right? Okay, so this is equal to tangent, tangent theta. Okay, and I'm not going to add c yet. I'm going to add c later once I'm done getting the integrals of both terms. So we have already found the integral of the first term. So let's go to the second integral, which is -4 the integral of with respect to theta. So this is -4 times theta, correct? The integral of 1 d theta, or with respect to theta, is equal to 4 theta. Therefore, the integral is equal to integral 1 plus integral 2, which is equal to 4 tangent theta minus, let's substitute, minus 4 theta. Okay, again, this is now the answer for this integral. However, if we're going to check our final answer to the given, the final answer that we have at this moment is expressed in terms of trigonometric functions, while the given has no trigonometric function, and the given has x, or expressed in terms of x. So we need to convert this, okay? So let's move on to the next slide. And again, we have identified that our final answer is 4 tangent theta minus 4 theta. Okay, so for us to convert this in terms of x, let's draw the triangle or right triangle again. And again, we know that this is x. Okay, let's check our triangles. X, 4, square root of, yeah, there we go. X and 4. X and 4, and this is the square root of x squared minus 16. All right, so tangent theta is equal to opposite over adjacent. So that's the square root of x squared minus 16 over 4. Okay, and for theta, okay, let's substitute that first here. So that's square root of x squared minus 16 over 4 minus 4. What is theta equal to? And we know that x, let's just go back here. We know that x is equal to 4 secant theta. So let's solve that here. X is equal to 4 secant theta. And secant theta is equal to x over 4, right? So let's solve that here. For us to find the theta, we know that it's secant, let me just copy. Secant theta is equal to x over 4, and theta is equal to the inverse of secant x over 4. Okay, so this is now our theta. So therefore, we can use this to substitute. We can use this expression to substitute to theta here. So this becomes secant, the inverse of secant of x over 4. All right, so let's simplify. I can cancel this out. So this is equal to x squared minus 16 minus 4 secant, the inverse of secant, I mean x over 4 plus the constant of integration. So our final answer is already expressed in terms of x. So that's the square root of x squared minus 16 minus 4 times the inverse of secant of x over 4 plus c. So this is our final answer. And let's check. Yeah, we get the same. Okay. So that's how we solve problem number 3. And I hope we got the same answer here. Okay. All right. So let's check if your answer is the same as this or if we have the same solution as mine. Okay.